Hi there! So as you can see, I'm working on a new video. This time, an interesting subject always, wireless communication is always interesting. And I got this old radio basically. And in this video, I just wanted to explore how easy it is to do wireless communication, audio communication with AM, so amplitude modulation. The kind of stuff that was pretty much done in the old days. You can still use it, there are still broadcasting channels, but not often used. So I will just explore just how simple it is to send AM waves and pick it up and how to receive them. And I'm currently at the transmitter station. So here I recreated a schematic I found on the internet. But it will not be one of the videos, testing circuits I found on the internet. This one with a 555 timer, and what it does, it's not really AM modulation, or you can see it really badly. What it basically does is it is using the control voltage pin to just like increase and decrease the off time. Like here in the high region of the sine wave, which I'm currently using to modulate, there you can see the frequency is around 513 Hertz. So on and off time is pretty much the same. But if we go to a valet where we like this, when the voltage is down, then you can see the frequency is higher because there's a lower on time. And that's the modulation in this case, but it works. That's the crazy thing about AM. There's so much you can do to just make it work. It doesn't have to be perfect, so it is something everyone can try out, and it's really awesome. So this is the wave that is currently on, and that is 600 Hertz. And if we play around with that, oops, I went one too high. Yeah, pretty funny. Yeah, and that's basically what I'm currently working on. Oh, it's too good. Even when I turn the volume down, you can still hear it very much. Okay, maybe the radio is just a bit defective. But yeah, that's the stuff that I'm currently working on. Hi there, I'm back at the AM radio project, and as you can see right now, as I'm talking, we will receive something. So why don't we just start the recording, and I will show you how it sounds later. And as you can see here is my small AM receiver station. Really minimalistic, so the video will be basically about you can 100% build this by yourself. This is just made of a small, how do I call it? It's basically a small IC which amplifies and then demodulates the AM signal. And for the input side, we got this self-made coil, basically an iron rod with 100 turns of windings. And then I measured the inductance, and I added a capacitor in parallel to basically build up a tank circuit so that it resonates near the AM frequency, which I'm going for. And then all around we got some passive components for the coupling so that the amplification is set correctly and that it does not over amplify, I would say. And it's a really simple circuit. You can make this, and as you can see, I'm basically with the cable hooked up directly to the output there at the capacitor. And fun fact, here is the oscilloscope. So we basically got the transmitter side, which is our AM signal at around 1 megahertz. And you can see as I talk, the amplitude is modulated. It goes up and down, and you can see that better with a wider time. So there you can basically see how the waveform, the amplitude gets modulated. And on the downside, you can actually see, I hooked up the oscilloscope to the receiver, what I'm currently receiving on the side. So seems to work perfectly fine. And now just let's stop the recording and actually start it so you can hear it. Of course, we got some static noise, but you can clearly hear my voice, I think. Yeah. So Works perfectly fine. Really good learning experience, I think, to understand how it works. And the video will come out soon, so I hope you're looking forward to that. Hi there. So I'm back in my living room, and yes, you might already know this setup. This is basically my bike generator. I did a video, I think, about a month ago, and the feedback from viewers was just so many good ideas that I thought, why not do a part 2? And that's actually what I'm doing right now. And I just got a huge success, I have to tell you. That's why I'm making this short clip. Usual setup, like sadly I could not use a light bulb anymore because I'm making too much power. I just wanted to show you on the screen, but now I would have to wait until 2 minutes into the video clip to show you that. But basically put, it is still the same setup except for one thing, and that was a suggestion from viewers as well. Basically it is a belt tensioner. So it basically pushes this up, and I constructed this little mechanism with 2 springs so that basically because when it is driving you can see it, it moves around the wheel as well, so there is not always constant pressure, but with the springs it basically is always tensioned, the belt. And that means that even when I'm using higher exciter currents, like maybe 2 amps, there is still enough force so that this thing turns properly. And basically just a small little mechanical construction. Okay, that doesn't sound too good, but it works pretty well. I had problems that the belt would slip off, but then I pretty much adjusted the whole construction because, as you can see, it is all a bit tilted. That's the big problem, but I got it to work, and guess how many watts I was able to produce? I'll tell you right now. With 6 volts, 2 amps in, so that's 12 watts in, I was able to measure, I think, 160 watts. So that's a plus of around 150 watts on my own. But I have to tell you, just producing this plus 150 watts, it takes a lot of force. It really is exhausting. That's why I'm breathing so much right now. But really exciting results. This is not the only idea that I will integrate in the video. This is actually just idea 1, which works great. The other ideas which I will try out very soon is a washing machine motor. How well does that perform? And then also another alternator, which is hopefully self-exciting. It only has 2 terminals, B plus and D plus. D plus is for the dynamo, telling you that 12 volts is created, and B plus basically connects to our load, battery, whatever. And yeah, I hope that will turn out just fine, and I hope you're looking forward to the video. So I'm making this clip because I'm at a point where I'm quite happy with my results. So the subject for this video is basically a current clamp like this. You might have actually seen one of those clamps in my videos. I use them, this one, it can do AC DC, so you can measure AC current and DC current, and it's a very handy tool, and I actually managed to break one of those. And while looking inside, I found out, okay, it's not that hard to build on my own, I thought, at least. So I started off with this AC current clamp, which is commercially available. And the problem with such an AC clamp, it's basically just a transformer. When you got an AC current flowing through it, there's an iron core, and then there's a voltage induced in the secondary, and you can see that on the screen, and boom, bada bam, it's an AC current clamp. But the problem is with DC, because when you push DC through such a core, then of course for a short moment when the current is rising, you induce a voltage, but after that, the magnetic field, the magnetic flux does not change anymore in the core anymore. That was twice anymore, sorry for that. And the problem is that basically you do not get a voltage on the secondary. So for that, the commercial clamp uses a Hall effect sensor. And this sensor basically can measure magnetic strength. And I actually, you can't see it right here, but I glued one in there. I removed a bit of the iron core and glued it there. Works perfectly fine. And then I searched on the internet for people who did a similar thing, because that's not new. But what I actually found were circuits which only worked with DC. The problem was that the op-amp configuration they used was only supplied with one one voltage from ground to positive, and I actually built a super crude version. It's basically just a voltage divider with two capacitors, you can see it right here, and that builds my dual rail. Terrible design when you think about it, but since I'm using a TL082, which is a JFET op amp, not the best for the job, but the thing is it has a very low current draw, so I'm not loading the voltage divider in this case very much, so the dual ray is pretty stable, and I can show you on the screen because now this should work with AC and DC, so it can not only go in the positive range in the DC but also the negative range in the DC, which is AC. And I just realized that I bumped the circuit and thus changed the bits, but yeah, you can see on the screen, oh boy, this is the output, and right now you can see here is the current that is now flowing through it. It's 0 to 3 amps, and with it I just adjusted the offset right here, and above is the amplification. And if I go now from 0 amp, 1 amp, 2 amp, 3 amps, so you can see the circuit definitely reacts to that, and that's the positive range. And if I now just switch the output terminals here, of course we reverse the current flow, so it should now go in the negative range. So let's see if that works. 1, 2, 3 amps. So yeah, it can go both directions. Basically what you want from an AC/DC current clamp. Not sure why I have not seen such designs yet. Maybe because it's not super precise. With such a voltage divider, what do you expect? Let's be honest. But I think just for seeing the waveform, and when you do a proper calibration beforehand, and then you can get some useful values from this. That's not a thing. It just takes a couple seconds more. So I'm now moving this to a perf board probably. I will do some more testing right now, and I will then see how I will continue with the video.